I would like to thank, first of all our great speakers that join us today to provide a little bit of insights on how satellite-based application can actually help regional and local authorities and actors. And yes, I mean, basically, I will briefly introduce for those of you that do not know it yet, the project eShape. So, as you can see here in the slide, eShape is a European Commission Horizon 2020 flagship project that gathered at the beginning of the consortium 54 partners, and now, I mean, more than 60 partners, especially after the latest onboard process, which ended a couple of days ago. We have more than 37 pilots projects that have been developed under the 7 showcases areas that you can see it here, ranging from climate, water, disasters, energy, agriculture, health, and the protection of our ecosystem. Basically, the project aim at gathering under this umbrella the European capabilities on Earth observation that are currently contributing to the EuroGeo initiative. And the project basically ultimate goal is to foster entrepreneurship in this sector and to support the uptake from final user, in this case specifically from local and regional authorities of satellite-based application. Next slide, please. Thanks. One of the main and most important characteristics of the project itself is the 3 pillars that are the basis of eShape, which is the co-design. That means that all the pilots project have been developed not only with the support of the user, but with a concrete, let's say, involvement of the final users since the very beginning of the process of development, to showcase that satellite-based application can be customizable and that can go and address the actual needs of the users. The implementation itself, which means that again, this is building and is actually developed on what is already existing in terms of the European Earth observation infrastructure, and eventually the user uptake, in the sense that this project is really aimed at supporting and boosting the ecosystem of Earth observation companies and stakeholders. So after this brief introduction of eShape, I will move directly to the first speaker of the day, that is Douglas Cripe, and I will immediately give him the floor after having said that Douglas is an expert on climate, water, ocean, science and technology, and currently is serving at the water coordinator as water coordinator at the Geo Secretariat and the senior scientist. Geo Secretariat, that again is the intergovernmental group on Earth observation based in Geneva. Douglas, I will give you the floor to, basically provide a little bit of information to our audience today on what Geo is doing and the relevance of eShape for you guys and for our community. Thank you.
Okay, thank you, Annalisa. It's a pleasure to be here. And as Annalisa mentioned, for those of you who haven't heard of GEO, GEO is an intergovernmental partnership that's been in existence since 2005. It came about actually as a series of Earth observation summits, so ministerial level summits, looking for ways to make better use of Earth observations for societal benefits. So GEO started in 2005. I'm at the Secretariat. I've been there since 2007, so I've been there for quite a while. And as a partnership, this means that GEO works in a non-binding, best efforts way to open up access to Earth observations and to find ways of applying them for, as I mentioned, societal benefit. And I thought I would just read to you quickly in the strategic plan for GEO, the GEO's vision, and that is that GEO is a global partnership of governments and organizations that envisages a future where decisions and actions for the benefit of humankind are informed by coordinated, comprehensive, and sustained Earth observations. And the mission of GEO is to work to connect the demand for sound and timely environmental information with the supply of data and information about the Earth that is collected through observing systems and made available by the GEO community. So we see that eShape is very much in line with this vision and mission. And it does so in the context, as Annalisa mentioned, of EuroGeo, which is a regional geo. You might ask, well, what is a regional geo? A regional geo is loosely based on the caucuses that exist within geo. In other words, groupings of countries, the Americas, Africa, Asia, Oceania, Europe, and so forth. And the reason why we have these regional geos is to promote common goals among regional areas. And this is in turn to enable or to foster data sharing. We find that when countries of a particular region, they tend to face similar problems or similar challenges, let's say, in terms of environmental issues. And if we can group them together and get them to work together towards a common goal in solving those issues, then data sharing tends to be easier to have happen. If I go back to the last ministerial that we had in Canberra in Australia, the declaration that came out of that ministerial notes that there's an increasing demand, an increasing need to connect GEO with key global and regional activities, and in particular, not just applications, but also for economic cooperation. So, for example, GEO has included Asia-Pacific economic cooperation. We have also worked with UNECE and others, and we are really supportive of this regional effort to get people to work together. Again, the declaration from Canberra says that the regional geos are an integral and a formal part of GEO that enables governments to benefit from the work of GEO while collaborating to tackle common challenges. So that's just from the GEO Secretariat perspective. I'm very encouraged to see what eShape is doing. The projects that are a part of eShape are very important, and I think we're going to look for ways that we can incorporate them into our GEO Knowledge Hub so that they can be broadened and upscaled for applications not just in Europe, but also globally to the extent that they are done in an open science way. So anyway, those are a few of my thoughts as we kick off the webinar. So thank you very much. Back to you, Annalisa.
Thank you very much, Douglas. And indeed, I cannot agree more with you on the fact that Earth observation information are currently very relevant for decision makers to make indeed informed decision, because there's no other data that can be more objective than Earth observation is. So it's indeed, I do understand the need also for the community to actually get access to those information to be able to make indeed informed decisions, and the need actually to share the challenges and to try to address it and to tackle it in a common way through information and shared endeavors in this sense. So thank you very much. I'm pretty sure that we will have like further questions also on the role and on the, let's say, priorities of GEO for the future in the chat later. So this said, I will move to Bente here for the second round of presentation. So Bente as well is a member of the GEO community since a long time, basically 2004. She engaged both as a representative of the GEO plenary and represents Norway on the GEO program board. Bente runs research and consultancy company, which is called BLB, focusing on transforming Earth observation data to information and knowledge for societal benefits. So here we go again. She will present on the power of integrating satellite data with in situ information for regional management linked to oceans. Thank you very much, Bente, for being with us, and I give you the floor.
Thank you very much. Thank you for inviting me. And now I will share my screen because I have a presentation, and I hope you can see it.
We can.
Yes, we can.
Yes. Okay. So now we are going to look a little bit into the details, what it means to actually use Earth observations, and particularly how we can combine satellite data or space-based data with in situ information to help regional management and more local management. I will use the case of the ocean, but this is also applied several places. Here's an example of me in situ. If you don't know what in situ means, it means actually on ground. This is the highest top of the island that you see here on the right-hand side, and this is a satellite image from Copernicus. And it was taken about the same time I was actually at this location. So I use this as an example for you to see the difference between space-based and in situ data, so you know what that means. And you can see here, by the way, this image here is monitoring. With this tool, you can monitor very small movements on the Earth, which I could not for sure notice when I was there at this mountain. Now, here is another satellite image. This is a visual one, optical one, and this is taken by NASA. And this is a point I will come back to. And these combinations of space and in situ, it gives us a good management tool. Here, we are zooming in on a location that I know very well. I will give you the names here. You have here Saltströmmen, which is the strongest maelstrom in the world. So that's the tidal effect. You have a city, a local city, and then you have a part of the fjord. And something happened here in situ observations here, but also services here based on both satellites and in situ observations. Here is the observations that was done in that ocean space. This is a shark. I think it's the largest shark in the world, actually. And it was done in situ by me. And here is, you see, the maelstrom. This is important to know for fisheries because this is a very rich area with rich on fish. So you use the observations to service the fishing industry, the tourism industry, and also transport, because going in and out of this strait here is kind of risky because of the strong currents. And we have then here a service called under Barents Watch, where you collect a lot of regional and governmental local administration data is collected and combined into a service where you see here when the current is going in and out, and when the key point for transport is when it's neither going in or out. So that's the calm period. So this information is provided very locally. So you are using satellites and you're using local information and you are giving a service. This is repeated, rinse and repeat for many different areas, topics. Now, going back to geo. So like Doug said, we think in geo that it would be beneficial to focus more on the local regions, but there are commonalities, and this is for the ocean. We have this Geo Blue Planet, which is one of the activities in the Geo Work Program, and the mission is to actually exploit the synergies from different observational resources. So I showed you a picture from NASA, which is the US space agency, and from ESA, which is our European one. And in GEO, we try to see the synergies and how we can optimize these resources that we are investing in. So that's one benefit from GEO. And also, there's a lot of commonalities when it's about engaging the users. So this is also something that we can benefit from doing on a global scale. And then, of course, same with creating awareness around the benefits, which is one of the reasons why we are here today. So that's one example. Now, in order for this data and information to actually work together, it doesn't happen by itself. It's very important, as Doug also said, to share the data. And what is one of the main outcomes and what we are proud of in GEO is the data sharing principles. And you may know that we have, in Europe, we have actually developed these ideas of data sharing also further, but for Earth observations, we are rather advanced because we are on a governmental level agreeing that the data should be shared to the largest extent possible. And going into even further details, never mind reading all these details, the point is that you see that we have data management principles to guide this process of combining satellite data with in situ data and other types of data like fisheries, accounts, economic data, etc. It all needs to be combined and made interoperable. And the process here is happening. You collect the data. This is just to show you that there's different levels from gathering the data until we get to the services that the society can benefit from. So you have the data layer, you have different types of resources that, for instance, in Europe, we have the Copernicus program, we have the DSIS, so the platforms that facilitate the sharing of vast amounts of data. And then we have the platform service layers where we can also, that help us transform the data into information and services and applications. And then the exploitation, how do we integrate this in the industry, in the public sector, etc. So these are the layers when you want to use the Earth observations. Now, in addition to that, we need policies. And in Europe, we have the digital decade now coming up with the European data strategy. We are talking about the different data, or what do you call it? We have data spaces for different areas, for agriculture, finance, the Green Deal, I'm sure you heard of, energy, etc. So we are looking to divide and structure the data that is available, and the European Green Deal. And for the ocean, we have the blue growth. So we have a tool set of policies to help also this transformation of data into services come about. And here, never mind again, this is just to show you the immense amount of resources that is available to us. The trick is actually how do you transform that to something useful at local level. That's really not happening by itself, but we do have a lot of resources. And the resources need to work together, as I said, and interoperability is a word that we use again and again. And the interoperability has to happen on policy level, on legal level, the licenses. You have to have, I mentioned reference frames. This is the Galileo program is a key here to define a common coordinate system, both for space and time. This is really important for interoperability. We need to use standards. We need to use good records of metadata, so data about the data. And we have the Inspire directive in Europe, which is really a very valuable source. I also mentioned already the data sharing principles. We have several others than GEO. We have FAIR, CARE, and TRUST. You have heard some of them. We are working on these because they can be used in different application areas. For instance, CARE is taking more care of the human perspective, which is, the personal individuals, which is often the case if you're using data from indigenous people, which is the case for us in Europe in the Arctic, just to mention some examples. Now, this digitalization is now expressed in what we call digital twins. And we are creating a digital twin of the ocean. And not a small task to do, of course. You see here, it's how do you describe this vast ocean digitally? Now, it's not like these two guys, which one of them is actually my father, to illustrate that there's a number of twins. And I will talk more shortly about the Iliad, which is one of the recent Horizon 2020 investment from the European Commission in a digital twin, or the twin of twins. But you see here, there's a number of other activities as well. The Mercator Ocean have a digital twin of the ocean. In ESA, there's also digital twins of the ocean. The Global Ditto is digital twin of twins of the ocean under the UN decade for ocean science that we just entered this year, etc. So I just wanted to show you that there are many digital twins, and not only in the area of ocean, and in many other areas as well. Now, coming back to a very messy slide, this is how we have divided the different stages and the different types of activities that is necessary when you are developing a digital twin, and this is for the Iliad project. So it's a European huge 17 million euros investment in Europe to build a digital twin. I see the time is running, so I will not go into detail and just show you the visual here that we have immense amount of resources. Here is, but this digital twins actually can go down to services on a very local level. For instance, you have harbor safety. Then you build a digital representation of your harbor, and everything that goes on there will be your twin, digital twin of reality. And so you have for all these different areas, for energy, for forecasting, coastal sediment, for pollution, oil spill insurance. Just you see there's a whole row of digital twins that will be built here in the Iliad project. And you need information about waves, wind, current, all of which global satellite images and satellite data combined with in situ will be key to solve this and to create these digital twins that you can use when you are managing your very local needs. You see here a map where the digital twins are placed. They are localized and they need to serve the local population. So that was what I had. I'm sorry for going over the time. I'm happy to answer questions. I guess that will be in the end of the webinar. Thank you very much.
Thank you very much, Bente, for indeed this very insightful presentation. And again, it's clear now that only like the merge between the in situ and the satellite information, like basically using the peculiarity of one and the other observations and information, we can take the most out of them and provide the best possible information to the different indeed potential users that, as you rightfully mentioned, I mean, it's plenty of different stakeholders, societal stakeholders and sectors. And thank you very much also for providing a little bit overview of the next indeed flagship European project on the digital twin of the oceans and how we will integrate like different kind of data from citizens data to indeed satellite data. So thank you very much, and indeed please stay with us because I mean, very likely there will be question at the end of the session addressed to you, so stay with us. I will move now to the next speaker, which is actually the first E-shape pilot that we have today. So it's about fishery in Portugal, and there is here with us today Aida Campos that will present to you with an hands-on presentation what the pilot is all about and how the users will benefit and how actually they are interacting right now with the users that are part of the development process. And just for the benefit of the audience, Aida is a senior researcher at the IPMA, which is the Portuguese Institute for Sea and Atmosphere. She's a national representative of the DGRTD strategic working group on scarfish, which currently she chairs. Aida has more than 30 years of experience in the areas of fishery technology, and today she will present the pilot on monitoring fishing activities. So Aida, I will give you the floor now, and enjoy the presentation.
Thank you, Annalisa, and thank you very much for the invitation to be here. I will share my screen. Okay, is it okay?
Yes. Yes.
Yeah. Put it in presentation mode. It's not on presentation mode, is it? No.
No.
But are you seeing it?
Yes, we do see it.
Okay. So I will present the pilot 5.5 on E-shape. It's a pilot led by IPMA together with Demos, and we call this pilot, we shortly called monitoring fishing activity, and it is at the scope of the showcase water resource management. Our objective in this pilot is to develop a web-based tool in support of fisheries management, and our study area is the Northeast Atlantic, comprising the areas of Portuguese jurisdiction, which are the red areas in the picture, including the continental EZ and the EZs of the Açores and Madeira Islands. What is the reason for this pilot? Well, first, because fishing is considered the most important human activity directly impacting the marine ecosystems. And we have a special concern on this impact in the oceanic waters over the deep sea. These areas are out of sight, they are under fishing pressure, and we are still trying to answer some questions on what are the fleets, the fishing fleets involved in these fisheries, the species exploited, where do these fleets operate and how do they operate? A second reason is because to answer these questions, we need spatial data, and the spatial fisheries data is already collected at the scope of EU monitoring programs. And it is extremely important that the information generated by this data is incorporated in conservation planning processes in line with the EU policies, the Common Fisheries Policy and the Marine Strategy Framework Directive. So this information is essential to operationalize the ecosystem approach to fisheries management and to contribute to an assessment of the good environmental status. A third reason for this pilot is because the scientific advice on which management measures are based may be required at a more regional level. And this calls for user-driven demand for research and innovation and the development of user-oriented applications. Also, another reason is because these data are collected through electronic monitoring systems. They are essential for the definition of management measures but their potential is not fully used in support to scientific advice. So the development of this web-based tool is a way to integrate information from fisheries monitoring data in support to spatial fisheries management. And last but not least, because this pilot builds upon previous experience in other projects coordinated by IPMA, where similar tools have been developed. So what is the aim for this pilot is to develop, as I said, a web-based tool providing a set of functionalities, including the exploration and visualization of spatial fishing information. So the objective is to provide maps on fishing intensity, landings, catch rates, and also the environmental characterization for the pelagic fisheries in these deep sea fishing areas. The key users are the Fisheries Portuguese Administration, DGRM, the Portuguese Directorate of Natural Resources, Safety and Maritime Services, which is the organism in charge of fisheries administration. And also other key users are the regional governments, scientific community, stakeholders, organizations, and international organizations, for instance, such as the Northeast Atlantic Fisheries Commission, which is the regional fisheries management organization for the Northeast Atlantic. What are the requirements? This application should be user-driven, so user-structured, user-oriented, and co-designed by the key users. They must be responsive to the needs put forward, and they must provide new solutions that we can use in research, management, and industry. It should deliver policy, economic, and social value, and it should demonstrate effective use of European Earth observation resources. What are our key data sets? The activity of the fishing fleets operating in these areas was analyzed based on data from two main sources, complementing each other, fisheries-dependent data on one side and Earth observation data. Fisheries-dependent data is collected by fishers, and these data are available for the Portuguese fleet under requirement to national authorities. As I said, the Portuguese Directorate for National Resources, DGRM. These data are confidential, anonymized data, and they are obtained through national monitoring programs, and they have provided long time series, at least some decades for some of this data, comprising vessel daily sales in auction, regarding the species catch and value, fleet technical characteristics, and also georeference data such as the VMS data. During the last 2 decades, this data have been added. So now we have data about the real-time positioning of fishing vessels and associated speed and course. And this system allows to define vessels' trajectories a long time. This system is also responsible for the emission of the electronic logbooks in which the fishing events are reported daily, along with information on the fishing gear used and catch by species. So these systems were conceived for the purpose of control and their potential to estimate the fishing effort and the fish abundance has not been fully addressed. A second source are Earth observation data comprising open access data obtained through EMODNet, such as bathymetric sediment charts, and also through the CMAPs, the marine component of the Copernicus program. EU data also comprised data acquired through external suppliers from vessels tracking systems, as it is the case of the automatic identification system. This is a system conceived for vessel security and makes available global information on vessel movements, including the fishing vessels all over the world. And the information provided by this system is similar to the VMS information, which is the real-time positioning of fishing vessels and associated speed and course. Unlike VMS, this equipment can be switched off, and therefore vessels can choose whether to report, which leads to incomplete coverage. On the other hand, it is characterized by a much higher frequency, so it allows to produce detailed trajectories for some sections of the vessel routes. So what are the fleets analyzed in this pilot? We started by identifying the fishing fleets engaged in the main pelagic fisheries taking place in the areas, and then characterize the fleet dynamics, including the spatial patterns of activity. And these two fleets are the drifting long line fleet for sword fish, and the pole and line fleet targeting the tuna fish. In the left top, you can see a Portuguese longliner, along with a schematic drawing showing how the lines are set in water. The swordfish, which you see on the right, is the main target species, but there is also an important and valuable bycatch of different tuna species, and also an unwanted bycatch of blue shark and mako shark. The pole line fishery, on the contrary, is a traditional and highly selective method to catch tuna by this Portuguese fleet, where fishers use a pole and line and live bait to catch different species of tuna. I will pass to our products or services, as you wish to call them. And the first product we are developing is fishing trip maps. Here you can see a fishing trip for a longliner operating near the Azores. Each trip is a vessel trajectory, starting in a fishing port and ending, in this case, in the same port, but it can end in another port, where spatial points form patterns. And from these patterns, it is possible to identify fishing activities and separate fishing from non-fishing points, that is steaming points. And this allows to estimate what we call here the fishing footprint. The vessel trajectory here is defined by AIS registers, since we didn't have VMS data available. And the separation from fishing from non-fishing points can be based on different criteria related to AIS points attributes, such as vessel speed and course. Second product, our second product is the fishing footprint, produced by displaying the fishing points in a grid. Here the spatial resolution is 0.1 degree, and you can see the fishing footprint map for the pole and line fishery for the period from 2014 to 2018. It is given by the total fishing time in number of days per cell, summed for all vessels in the fishery. We used a speed-based criteria to separate fishing from non-fishing points. And so we can see that this fishery occurs in two EZs, Azores and Madeira, and also between the two archipelagos, with higher fishing pressure in the vicinity of the islands. In this phase of the pilot, the quality of the data provided in e-log books did not allow to produce maps of fishing efforts and fish distribution, but the results from monthly sales allowed to produce seasonal maps of the fishing activity, and we clearly see that the fishery is concentrated in the second and third quarters, starting in April with a catch of big eye tuna and ending in October with the skipjack tuna. Our third product is maps of sales in the different ports for the species the main species targeted by these fisheries. What is our expected outcome? In this pilot, we are extending a previous application developed at the scope of the projects BioMetor and CBO data, which were two EA grant projects led by IPMA. Here, VMS and e-logbook data were used to create interactive maps where either the fishing intensity and the catch distribution can be visualized according to the gear used, the species captured, the time of the year, etc. In the current application on the right, we aim to provide interactive maps on the pelagic fishing activity for these two fisheries, the drifting longline and the pole and line fishery, including the fishing trips, which you can see here in the figure for the drifting longline, and also environmental characterization for these oceanic fishing areas. In this pilot, we have a lot of challenges related to co-design. A co-design process is being undertaken with the key users, and for this purpose, online meetings have been carried out, and more recently, an online survey was issued with the purpose to assess the user requirements, either in terms of key data sets or of the products to develop, including limitation for the use of possible limitations for the use of this data or these products. So we are now working in improving our products. The data used so far in the development of these products were daily sales in auction, vessels characteristics, and satellite AIS data. E-logbooks were recently available, so only from the start of this year we started working with the logbooks. They are being analyzed in order to improve our fishing footprint maps and try to estimate fishing effort. VMS data were not made available for this project until now, and new products relating fishing distribution with environmental data are going to be also are planned to be developed, and this represents a step further exploring the potential of observation data. Catch reporting data, when coupled with the georeference data, allow mapping of fish distribution and abundance, but the integration of these different sources can be extremely challenging, given their availability of data and the quality of data and their different temporal and spatial resolutions. So improving the products is now dependent on improving the number of data sets and their quality, and we need access to high quality monitoring data for all fleets, and this is important not only for Portuguese fleets but all fleets that operate in this area. So the access to this data is absolutely essential, and there is a need for strengthening collaboration between all organizations responsible for this data. So data sharing is a relevant aspect among data providers and product developers. And I think I exceeded a little bit time. I want to thank you, and I'm ready for any questions I am able to answer. Thank you.
Thank you very much, Aida, indeed, for this presentation on the project. I mean, for the details that you provided to us. As you mentioned, we are running a little bit over time, so I will be fast in introducing the next speaker today, who is here with us to represent also a case in which the satellite-based information and data came to actually complement and improve the product and services that the SME was providing to several regional authorities, and is today explaining to us how they managed to integrate the satellite data in their business model, and what meant for them in terms of accuracy and also time series of the information provided. So I will introduce Gregoire. Gregoire is leading the efforts at Plume Labs in terms of data fusion. Is a company working at democratizing the access to air quality information and helping individuals to reduce their exposure to air pollution. So it's leading us to the next, let's say, big topic, which is health. And Gregoire, the floor is yours.
Okay. Can you see my presentation?
Yes, we can, and we can hear you.
Okay, perfect. So hello everyone. So I'm Gregoire and I'm head of data at Plume Labs. So I present you what we do with a particular focus on the data sources we use, and in particular on satellite data. So Plume Labs is a company working on democratizing the access to air quality information through three main products. So our first product is Flow. Flow is a wearable, low-cost air quality sensor for individuals, so you can bring it with you all day long, and at the end of the day, it provides you information about your personal air pollution exposure. Our second product is an air quality data API, providing individuals, researchers, or businesses with global air quality data. And our third product is a free smartphone app, giving users localized air quality forecasts in a similar way than a weather app would give you weather forecasts around you. So now I'll describe with more details how exactly we build our air quality data. So the first thing is that it's important to note that providing relevant and accurate air quality data is a very challenging topic. And the first reason is that air quality varies a lot, both in time and in space. So for example, a few minutes of rain can completely remove particulate matter, which is one of the main air pollutants from the air, and hence reduce drastically the level of air pollution in a matter of minutes. And a second example is that a crowded street with a lot of traffic can be 5 or even 10 times more polluted than a park which is 100 meters away. And the problem is that the available information about air quality is clearly not enough given this high variability. And basically, two sources of air quality information are available. The first one is monitoring stations measurements. So those monitoring stations are set up by governments and official agencies, and hence the quality of the network depends a lot on the countries. And the second source of air quality information, which is more and more used because the quality is much better 1 year after the other. So it's satellite measurements, which have a global cover, but with poorer spatial and temporal resolutions. So let's get now to the details of those two data sources of air quality information. So yeah, you can see on this map here the monitoring stations. So every white dot on the map is a station measuring the main air pollutants, generally on a hourly basis. So there are about 15,000 of them worldwide, and it's a very valuable source of information, but there are clearly not enough stations to represent the spatial variability of air pollution I mentioned before. For example, as you can see on this map, in some parts of the world, like Africa or South America, for example, there are almost no monitoring stations, and hence no hyperlocal informations about air quality. And even in places with lots of monitoring stations, and typically, for example, in large cities like New York, London, Tokyo, or Paris, for example, there are typically dozens of monitoring stations. And even in those cities which are quite well monitored, like a few dozens of stations is not enough given the very high spatial variability of air pollution. So to summarize here, these data source, monitoring stations measurements, are a very valuable source of information, but is clearly not enough to have an accurate and relevant view of how air quality looks like in a given area. So let's get now to the second data source, which is satellite data. So typically, satellites go around the Earth and provide measurements of different atmospheric parameters and atmospheric pollutants. And a given location on Earth is generally monitored 1 or 2 times a day when the satellite goes over this point. And the measurements have a spatial resolution, which is generally 10 or a few dozens of kilometers. And there are now a few dozens of satellites running and dedicated for atmosphere monitoring, and which all monitor different atmospheric parameters or pollutants and at different times of the day. So you can see here on this map, for example, the measurements provided the nitrogen dioxide, which is a pollutant. So the nitrogen dioxide measurements provided by a satellite dedicated to actually monitor nitrogen dioxide. So to summarize on this source of information, which are satellites measurements, it's very valuable as well because it has a global cover, unlike monitoring stations, which are very sparsely located on Earth. However, the temporal and spatial resolutions are quite poor. Temporal resolutions are around like 1 or 2 measurements a day, and spatial resolutions are 10 or a few dozens of kilometers, which is not enough. So now that I have introduced our 2 sources of air quality information, I can get to a more precise description of our modeling framework to actually be able to forecast as accurately as possible and to predict air quality globally, combining all those data sources. So the first step is to actually collect all data relevant to predict air quality. So the 2 data sources of air quality information introduced before, monitoring stations measurements and satellites measurements, but also some other data sets which are relevant as well, like traffic data, weather forecasts, the topology of the road networks, which is a proxy of traffic in locations where no accurate traffic data is available, and also land use data, which gives a description of the land, like where are the forests or parks, for example. And once we have collected all those data sources in real time, we have actually developed our own machine learning and deep learning models to be able to combine seamlessly and as efficiently as possible all those data sources. And to describe quickly how it works, what will happen is that when you want to build an air quality prediction in a location with no monitoring station, the forecast will be mainly driven by satellite measurements, and because it is the best and the only information we have. However, in locations which are quite well monitored with monitoring stations and other data sets like traffic data, accurate weather forecasts, and accurate land use data, for example, we will combine satellite measurements with all this information to actually be able to have a much more accurate and granular and high resolution air quality predictions. So if you are curious about our modeling framework, we have actually published 4 papers about our methodologies and models, which are available. And I would like to conclude now by mentioning our live air quality map. So we have released a free air quality map, which can be accessed at the link given on this slide. And it actually provides global air quality predictions with a resolution adapted to the available data and to the location. So in large cities which are well monitored, so for example, the example is a screenshot on the left here, it's a city in south of France. We can get up to 10 meters resolution and have really a street by street map in such cities which are well monitored. And in other regions, we will remain to poorer resolution, like 1 or 2 kilometers, because we do not have the available data to get to a much more granular resolution. So that's all for me. Thank you all for your attention, and I'll be happy to answer any question after.
Thank you very much, Gregoire, and indeed, please stay with us for like the roundtable at the end of the presentations, and you will be able to reply to additional questions from the audience. So again, now we can, having breached a little bit this two, let's say, domains of maritime and health by understanding how the integration of different data can provide information to the user, we move to the second e-shape pilot, which is presented here today by Jana. Jana is a professor of environmental chemistry at Masaryk University, and she is the director of RESETOX, which is the European Center of Excellence in Environmental Health Science. So Jana, the floor is yours, and we look forward to understand a little bit better what you are planning to do with this project. Thank you very much.
Thank you very much, Annalisa, and thank you also for inviting me. Do you see my presentation okay?
Yes.
I assume so.
Yes.
Thank you. So I will talk today about our activities focused on surveillance of pollution with persistent organic pollutants. So at the beginning, I will say a few words about our RESETOX Center, then I will continue with introducing the e-shape pilot, and then the specific product, which is the GMP data warehouse. And in the end, I will also introduce how this tool can be used and shared with the users. So the RESETOX Center of Masaryk University in Brno, Czech Republic, is the university institute that is focused on research and education in the area of environmental health sciences. And it is, as you already said, the European Center of Excellence in the exposome research, granted by the Horizon 2020 teaming project. It has several research programs looking at the environmental chemistry and modeling, environmental toxicology, organic photochemistry, protein engineering, and environmental epidemiology. But the important thing is that it is also open access research infrastructure that is providing a lot of services to both public and private sector supporting the excellent science. And it is currently the coordinator of the new European project of the research infrastructure supporting the environmental health research as one of the activities of the European Strategic Forum for Research Infrastructure. Also, RESETOX works as a science to policy platform. So we have a very close collaboration with the national ministries, but also environment program of United Nations and the World Health Organization in really connecting the research results with the policy and society applications. So the area of research and all the activities of RESETOX Center is very much aligned with the European priorities, not only Ostrava Declaration, but also the new Green Deal for Europe, especially in the area of toxic-free environment. And it is also in line with the Horizon research priorities, both Horizon 2020 and Horizon Europe, especially in the area of human exposures to toxic chemicals. We were active part of the joint European program, Human Biomonitoring for Europe, and we are also actively participating in the new European Partnership for Assessment of Chemical Exposures. Most of our activities are, however, global because we are supporting the UN conventions, especially the Stockholm Convention on Persistent Organic Pollution. And I should say a few words about the implementation of the Stockholm Convention, because one of the very important tools of the Stockholm Convention is so-called Global Monitoring Plan, which is the ambition to develop the system that can collect the information about the global status of the pollution with this type of pollutants, and also the tool that would enable sharing this data with multiple stakeholders. And such global monitoring plan should be updated every 6 months, every six years to enable assessment of long-term threats. And since the beginning, there was an idea of connecting this new GMP tool with the implementation of the GOS strategic plan to really support the wider exploitation of available data and, you know, building the EO linked tools. So the specific goal of our pilot is to increase the availability and quality of information that is needed to assess the fate and impact of persistent organic pollutants in the environment, and also to anticipate changes in the global environment. Because if we really want to see whether the Stockholm Convention is functional, we need to set up some kind of efficiency monitoring, which is why we need to repeat the exercise every few years. And also the ambition was to develop advanced web services that would really enhance the usage of the data and make it useful for multiple stakeholders. So to understand the design of the tool, you have to understand also how the data are collected. So the whole global process is based on so-called regional work organizing groups. So the data collection process is based on 5 UN regions. Each of them has the regional working group who is identifying the sources of data, communicating with the local stakeholders, and also acting as a QA/QC body, checking for the quality of the data and for its availability. So in the first phase, our tool has to serve for those regional organizing groups, really working with the multiple owners of the data, checking their quality and transferring all data into this harmonized document. In the second step, then, we need to provide the regional working groups with the tool to present the data and inspect them and approve them, because the regional reports are the subject of approval of the Conference of the Parties of the Stockholm Convention. In the next step, all 5 regional reports are merged, and we need to support the preparation of the global report, which is again the subject of approval of the Conference of the Party in the next few years. And then finally, when all the data sets and the visualizing tools are approved by the Conference of Parties, this becomes publicly available. So far we have 2 full rounds completed already, and we are in the 3rd phase of the data correction, the 3rd data point. So what our data management tool needs, we need to provide online platform for data reports for their approval, and then data visualization tools for to present the spatial distribution, availability of the data, summary statistics, and trend analysis. So I will just quickly walk you through the different consoles to give you an idea of, you know, what kind of services we can offer. This is showing the spatial distribution of the data. So in all the maps, you can inspect what kind of data we have. You can see that those are land-based measurement, but also data from various cruises monitoring the quality of surface water in the oceans. The second option is to check the data availability in time. So you can see various data providers and what kind of data for specific chemicals they are offering throughout the history. Then we can see the summary statistics, so the overall picture of what are the actual levels of all chemicals. You have to understand that we are talking about, roughly 100 of different types of chemicals, because Stockholm Convention is the life convention. So there is ongoing process on how to include more toxic chemicals into the list of the convention. So we are working with really increasing set of the compounds, and the data management tool has to be updated every few years. Then this is also a tool for analysis of the time trends, because I explained that the final goal of the GMP is to check the effectiveness of the Stockholm Convention. So we really have to see whether the levels of the chemicals are decreasing over the time after the signature of the Stockholm Convention. So there are color-coded dots here showing whether the actual levels of the chemicals are increasing, decreasing, or stagnant. So this is how much we can offer, and now a few words about how this type of data can be used. I was talking at the beginning that our center is center of excellence for the exposome research. So what is the exposome? The exposome is kind of keyword that is in the European research area in the last 10, 15 years. And it is kind of a holistic approach to the environmental exposures. So exposome doesn't mean only toxic exposures, but it also means the exposures to the all kinds of food, psychological stress, social and economic environment. So it is a complexity of various stressors that can affect the human health and development of the chronic conditions. And to assess such a complex world of the various factors, we really have to develop a very broad and holistic data centers that can address various factors. And environmental factors are just one of them, because we need to monitor many other players that are affecting human health. A very important tool to study development of chronic diseases are human cohorts, and there are multiple human cohorts and multiple European projects that are trying to harmonize available data from such cohorts. The available data from the cohort can tell us something about the human health. They can tell us also something about the lifestyle, their nutrition, consumption of the alcohol or smoking, their physical exercises. But they can also connect their internal exposure, the levels of the chemicals in their bodies, but they typically do not collect information about the external exposures, about the status of their indoor and outdoor environment. So this is an opportunity to merge these type of data sources and start building the interdisciplinary platforms that would allow us to connect the health data with the environmental data. And this is something that we are piloting at the local or regional scale, because we are very lucky that city of Brno in South Moravian region of the Czech Republic has almost 60 years of history of the various population studies. The first birth cohort was recruited in the region already in 60s. There was the second one in the 90s. The third one is being recruited right now. But there are also the cohorts of productive age and aging population, which gives us a lot of information about the lifestyle, social economic conditions, psychological stress, and also the health of such people. And we are trying to build a knowledge platform that would allow us to connect this information with available data on the environment. So what we are offering is really modern multi-modular data repository that is fully parametric, that provides the standardized tool and also the transparent multi-layer procedure for validation of the data. And these tools can be used in future European projects. I mentioned already the HBM for Europe or PARC partnership, but we are also part of several Horizon 2020 projects focused on human exposome, typically EXPANSE project, which is the project that is focusing on urban environment and its impact on human populations. So this is the type of the project where we can contribute with our data and provide one layer for the evaluation of the impact of exposome on human health. What is there in the future? I said that currently our tool is visualizing the data from first two campaigns of the global monitoring plan. But all data for the third GMP report is already there. The regional report have been approved and the global report will be approved next year. So right after that, all data will be publicly available there for multiple stakeholders and users. And it is already available for various research projects now. So thank you very much for your attention and happy to answer any questions.
So thank you very much, Jan. I mean, this was a great overview, and I mean, I got to understand a lot of new things, and I mean, for sure, we realized today, I mean, not today, but in general terms, today was again demonstrating how important it is to be able to integrate different sources of information to get the most insightful information for different domains. So before opening up the floor to the open discussion, I would like to give the floor to Ms. Roya Yazi. She is the Secretary General of Nereus, which is the network of European regions using space technologies since 2009. And she is leading the Brussels-based secretariat, and she is, of course, the main interface for all the European institutions, the European stakeholders. We wanted to have Roya today because indeed she's managing and operating the network of regions that are already using satellite space information, and we would like to know from her more on the feedback of the local actors that are indeed currently using operational solutions. So Roya, the floor is yours.
Thank you, Annalisa Donati. I'm very pleased to be with you here this morning. Thank you for the invitation, and compliments to the speakers. Was very interesting, your presentation and the way and context in which you use Earth observation data. What we want to share with you, let me see if it goes in the camera. I maybe take away my background that you can see the publication. It's here. In that context, we like to highlight the Copernicus for Regions initiative that brings together 99 user stories, how regions successfully use Copernicus in a broad range of user domains that are very relevant for the local and regional level. We brought together, we grouped them around 8 application domains, and a lot of them trigger the same topics we heard about this morning. A very important one is territorial management and urban planning, like we saw the examples this morning. But what is maybe interesting about the Copernicus for Regions collection, it's that's a work of volunteers. We made a call, we received stories, and we portrait them. And it's about community building. It's about bringing together different regional stakeholders to look how can we promote, how can we better advance with the youth at local and regional level. And our objective with these stories is really to stimulate interregional collaborations, knowledge sharing, sharing of best practices to better understand what you can do and how you can do it. For this presentation, we are now currently in a quite important stage because we launched this collection in 2018. And in the meantime, we developed different tools and research engine, videos, information sheets on special domains. And we go back to the authors and consult them, ask them, how did your application develop? What were important milestones in the last 2 years? And we got nearly from half of the players' responses, and we see that there are some evolutions in terms of regulatory, in regulatory terms. It's more and more in those cases where it's successfully, it plays an important role for the administration, and there are also technology advances. There are advances in the user maturity. And we invite you to join our webinars, the Copernicus for Regions webinars, and will in the next months share with you examples where we portray those evolutions and want to offer regions also a platform to discuss the evolutions. With this, I give the floor back to Annalisa, and I'm here also for questions you might have.
Thank you very much, Roya. And again, on my side, I will now move to the opening of the roundtable. And for this reason, I give the floor to Francesca that will moderate this session. Thank you very much to everybody.
Thank you very much, Anna, for this and for introducing our wonderful speakers. That every time in these workshops really highlight as, you know, very, very important usage of Earth observation data. And of course, taking, you know, retrieving from Roya's presentations on the introduction of the Copernicus for Region initiatives. Roya, you know that, of course, we have many successful examples of Earth observation, so at regional and local levels. However, they're still considerably more like innovation rather than practice. So I wanted to really ask you, as the Secretary General of Nereus and your daily involvement with regions, what have been the outcomes of these consultations that you've launched through these Copernicus region initiatives? You mentioned, for example, the user maturity. So what can we see in terms of user uptake, or, you know, to draw a line on this for the future uptake of these solutions?
Generally, what you can say, or what we also learned with the consultation, you have to look at it more holistically. You cannot only look, is there now the innovation, or is it now really how many administration use it? You have changes go step by step, and you have to look at really from different angles. And where we were pleased, we could see increases in the user maturity level, like they were moving from, let's say, 3 to 4, or from 1 to 2. It's not drastically, but there is. But what was even more interesting than are the other ones. It's like regulatory domain, where the respondents state the solution has helped to inform the design review of policy parameters, or there were improvements in the policy monitoring capabilities of public authorities in charge, or the solution has facilitated or improved the complications and complexity of institutional reports. You could give more concrete information, and that helps in the long term to develop more effective policies. Or the solution has improved the public authorities' capabilities to detect and access non-compliances and better respond to them. When it comes to entrepreneurship and innovation, this is a very important element, and we should not be too limited. Public sector innovation is a complex topic, and you need to bring more things together, but still, through the introduction of the usage cases, innovation in the public sector and efficiency has improved. There were positive market externalities. Yeah, the service provider could expand and get the market share. Those two elements are really important. Societal benefits. Civil security has improved in public awareness, or improved coordination and governance.
Thank you so much, Roy. Indeed, I mean, it's a challenging domain, of course, to take in considerations to expand ERS observations. But of course, your involvement, EURISI, ERS, SEBS studies, cases, for example, that our associations, for example, wants to bring forward as much as we can to really accommodate, let's say, this full knowledge. And I would like then to pass a little bit on to Douglas and Bente, therefore, from a geo point of view as well, because as Roya mentioned, Copernicus for Regions is about community building and about different regional and local users, of course, and sharing experience and practices and knowledge. And GEO, of course, being an intergovernmental partnership that works together with regions, local authorities and countries. I wanted to ask you how really, Bente and Douglas, you can take it from there, how the regional and local component can really be injected and how regions can benefit from GEO. So Douglas, already there are different working groups within GEO, and initiatives, for example, for which both Aida and Jan as well are part. So can you expand a little bit on that? And Bente, if you want to follow over, of course, you're welcome.
Okay, so the what is interesting about EuroGeo is that you are, and eShape is a big part of this, is that there are a lot of projects that exist already. We've seen several of them this morning. And what's important is that, they receive funding from the Commission, they go for 2 to 3 years, and then they come to an end. And of course, as we've heard in times past, what happens to the legacy of those projects? How do we keep from losing sight of them? So we have started and I mentioned this earlier in my presentation, we have started what we call the Geo Knowledge Hub. And essentially the Geo Knowledge Hub is going to be a place where projects can live on once they reach the end of the project lifetime. And what the Knowledge Hub features are end-to-end solutions using Earth observations, tackling some environmental issues like we've seen today. So what I see is that in terms, let me back up. What I mean by end-to-end, I mean that in what we are calling a knowledge package, you would have papers that describe the methodologies that are being used. You would have the data that was used in a particular project. You would have all access to all of the code and algorithms, the computing environment that was used, and the results that were obtained. And if the project led to the development of a tool, then we would orient the knowledge package towards people using that tool, kind of in a capacity development role. If, on the other hand, the project leads to an application of some kind, say you want to do land cover classification or what have you, then the project was developed. The application was developed over a particular region, in Europe, for example, but it is a methodology that could be applied elsewhere around in other European regions or even beyond that. Then the Knowledge Hub would be a way to share that knowledge and allow people to adapt the application. So the application or the implication here is that the application will be developed in an open science context. So that's one way that GEO is trying to take applications that are developed, at maybe at a national level, even not necessarily regional, but then upscale them so that they could be applied elsewhere in a given region or even globally. So that's one thought. And then just real quickly, before I yield to Bente, GEO again is with this regional approach, we are trying to find ways that similar problems can be addressed. We're trying to find actors who have a common stake in finding the solution. So the regional approach tries to foster this. Sometimes it's easier to outline and solve a problem at a regional level than it is at a global level, say, or at a national level. There may not be the capacity to tackle it. So at a regional level, you would have access to other institutions that could help you in applying Earth observations to solve whatever issue. So over to Bente.
Thank you. Thank you, Gregoire. Thank you, Douglas. Sorry, Bente, go ahead.
Yeah. So you covered a lot, but I was going to comment and maybe ask, because Copernicus is considered one of the major contributions from Europe to GEO. So so Copernicus for regions is sort of regions within EuroGeo then. And could be considered, I don't know if you are linked to EuroGeo at all with Copernicus for regions. It sounds like it's more coming bottom up from national programs. I mean, in Norway, for instance, we are investing in the Copernicus program, and we do have activities related to exploiting Copernicus because we invest a lot of money in it. And that's sort of independent of the GEO membership. We are also actively engaged in GEO, of course, but it seems like there could be potential better synergy with Copernicus for regions within the EuroGeo context. The benefit that we see from both from the national perspective, from regional, in this case Copernicus, and from GEO, is that the very first images I showed is that there are resources not only in Europe, but there are resources from other parts of the world, the NASA, but you also have a lot of resources being developed in Asia. So there's an abundance that can benefit all of us, all the way down to local level, by both having local activities and global activities. So I see that this is the advantage of being part of the community, a global community, as well as a very local community, because in the end, for instance, this global models of sea level, for instance, when you have a community, a small village or something by the sea, the resolution is simply not good enough for them to actually make decisions. So you need to have something in addition to the global, but you also need the global. I think in Norway, this is a very good example, and I think in Portugal as well, where we have so vast areas of ocean where in situ is very difficult, right? So we need the satellite images. I think who was it? I think it was Gregoire who really showed this in a very good example on the complementarity there. Yeah, thank you.
Thank you so much, Bente. Exactly. So you were really mentioning the local and global, absolutely. And how can we connect, let's say, more now, like the local with the satellite digital data? No. So one very important feature of eShape, and I will connect then also with you, Bente, but also now with Jana and Aida, also to reply to one of the questions in the chat is the co-design activity within eShape. So in eShape, it's and as well as Annalisa and all of you highlights, is of paramount importance for our pilots. The inputs, the feedbacks from private users or from other target users communities, which can be more public regions, for example, regions, public authorities, or local communities, like especially in this workshop. It's really important. So the idea to co-design a final solutions with inputs from other potential users is very important. And of course, not only initiatives, but will also be developed in future projects that also you, Bente, for example, Iliad, for example, you mentioned, or potential digital twins as well. Aida, I have a direct questions for you, for example, from an attendees, and I have it here. Sorry, Anna suggested to me. In particular, is how can maritime regions benefit from Earth observation data? In particular, the co-design approach and customization that you are developing can be scaled, transferred to other regions. And if this is the case, can you share some example on this?
Yeah, thank you. Well, in this particular pilot, as you already saw, we are using a lot of types of data. It's, in my opinion, it's a special characteristic of our pilot is that we are using Earth observation data only in a part of our products. Let's say that we need to build a base upon which Earth observation data can be used. And this base is, as I showed, maps of fishing intensity. And for this, we depend on regional data from the Fisheries Administration. So we are in a level that we are trying to gather this data and trying to do as much as we can from this data, from the analysis of this data, which is not easy. There's a lot of challenges in analyzing this data, so that we can build maps over which we can then collate environmental information, environmental variables, and can say forecast the probability of fishing in the different regions of a vast area, which is the Northeast Atlantic. So I think it's a big challenge in this pilot is to gather enough data to have a basis upon which we can work. I don't know if I was clear.
I hope. I mean, for us, I think it was very clear, and I hope also for our attendees. And I'm sure that if we'll have further questions, we can also put you in contact. So
I could add up a little bit more and say that our objective is to develop a web-based tool, and this web-based tool is a wonderful tool for support to fisheries advice. But not only, it's also a very useful tool for exploratory analysis, for research, and also for the users, the final users, the fishermen. And depending on the level of access to this tool, we can see our answers, part of our questions answered, where are they fishing, what are they fishing. If we link this information to the fishing logbooks, we can see the amount of fisheries of the different species, the fishing distribution, where these pelagic species are based, which areas are they distributing, how this is related with environmental variables. This is migrating species as tuna, swordfish. So I think that we should we will I'm certain that we will end with something very useful for fisheries advice.
All right, thank you, Aida. And this customization, therefore, is it sustainable also for private users? It can be customized also for a specific type of usage. Can be from this question I can understand, maybe from other regions, maybe from Baltic regions or northern regions. This can be done.
Yeah, this can be and should be upscaled, used in whatever regions, whatever areas by fisheries administration, but also end users, other stakeholders, the research. Depending on, of course, on the products we develop and on the degree of access to that tool. Because fishing, it's an economic activity.
Absolutely.
So we have persons depending on this, and there's an issue related to data confidentiality, and that's why I was talking about the VMS data, which are not readily available. They are confidential, but we have another type of data, which is the AIS, the automatic identification system. And so we can question what is the reason for so confidentiality. Of course, that we should show aggregated data, not referring to particular vessels or owners or whatever. But with the AIS data, we have now the issue of confidentiality is a bit, out of date. Anyway, we have a problem of governance for fisheries, but also data governance.
Okay, it will be tackled absolutely very soon. And thank you, Da. I would like to ask the same similar questions to Jana for his pilot. I'm sorry, apologize. And again, Jana, also your pilot is being co-designed with through you and your university, and with final target users as regions and local authorities. You particularly mentioned the Stockholm Conventions, absolutely, to support administrations. And how in particular are you engaging with GEO in this co-design activity? So I'm making reference a little bit to Bente's presentations on different resources, Douglas' presentations on the different working groups, and of course, you are also in the Goals for POPs working group in GEO. Can you expand a little bit on that, and then how this co-design could also be expanded and uptake to private users, for example?
Specifically for our activity, it is very important that toxic compounds, persistent toxic compounds, can't be measured from the satellites. So typically, what we have is on-site measurement, and it is also one of the major challenges because we don't have the networks that would be dense enough to really support, the large population studies. So we need to combine somehow on-site measurements with the satellite measurements. And I was talking about a holistic exposome approach. Of course, the part of the exposomes are not only toxic exposures, but temperatures, disasters, and other things, the atmospheric particles, gases. So what we have to work on is how to better integrate the data on POPs and mercury with ongoing measurements that are already available from satellites. And then to connect this not only to the cohorts, but the national health registers. I was specifically talking about the cohorts, but we also have the regional pilots where we are connecting the environmental data with data from the health register, which can give us the first indication about where are the major impacts. So again, working with the health data is quite challenging, and there are already European projects that are looking into the better harmonization of the registers and availability, because of course we are talking about GDPR and other restrictions. So we really have to find the ways how to make more health data available for these kind of studies. And of course, once we have some indications about the impact of multiple environmental and social exposures on health, that would open the space for the applications coming from the private sectors, like, you know, the tools that would support the personalized medicine, for example.
Okay, and I understood. Thank you. Thank you very much, Jana, for this. So it's 11:41. We are already 10 minutes late, so I think that with Annalisa we might wrap up a little bit this very interesting roundtable and panel discussions. It was really just the opportunity for us a little bit to have your inputs on this and drive and strive a little bit from your questions, and hopefully we gave good food for thought as well to report a little bit also for the Committee of the Regions on through this workshop. So there are many points on which I would like to talk about more. But I get to the main takeaways exactly that we can retrieve are really the importance of GEO on this for eShip and how this eShip can support the EuroGeo approach. And of course, how Earth observations, satellite data combined with actually in situ data are actually maybe the magic and also the way forward to see more examples of private users that are gonna use more satellite data is an example, for example, from Gregoire, that it was really, I think, lampant for us. And I also would say that health and fisheries has been two challenges pilots as well, I guess, to present a little bit, but I think there are many challenges that have been very highlighted and interesting to tackle, of course, in maybe other workshops. So Anna, do you have any other takeaways or any other points you would like? And as well to the pilots and speakers, if you have any last inputs that you would like to share. Otherwise, I would like to thank everybody, of course.
No, I think that you covered, I mean, indeed, major takeaways and lessons learned, let's say, from the presentation of today's speaker. And I would like just to join in thanking all the speakers today. It was indeed very interesting to understand a little bit better how in domains that might look a little bit different, satellite data sets can provide, I mean, very relevant information and can support in the provision of really like accurate and let's say actionable information for decision makers. So I just thank all the speakers again.
Thank you very much.